Good morning to ladies and gentlemen. Today is the second part of the electrical fires in building. Mitigation techniques and building classification. One is global standard and Indian perspective. Very important subject. I'm very, we are overwhelmed with the response. So we have almost 1,200 registration from all across India. And I'm very happy to see that a lot of corporates this time has joined the webinar. While we are on this subject today, hope you have seen the news. Early in the morning today at 2 o'clock, there's a 20-story building called Kamla building in Mumbai. Went into flame on 18th floor. 2 people unfortunately lost their life, and 15 people supposed to be injured in the fire. So this is the common news that we get every day. Some hospital are on fire, some buildings on fire, some warehouses are on fire, and some malls. Where I'm from Bangalore. I stay very close to the recent fire called the South India Mall, which is around 2 kilometers away from us, entirely burned down. So the fire happened at 3 o'clock in the midnight, and the cause of all this fire is simply electrical short circuit. Today, I'm sure Mr. Gopak Kumar will touch upon the reasons and what are the, very important to, listen from him, the causes for this fire. And today's webinar is an initiative from Cape Electrical, who's celebrating the 25th year of existence in Indian market. Cape Electrical, the Electric Private Limited, established in 1996. Cape are the first and front runner in various technological products in India, be it lighting protection or electrical insulation materials. The reactive power compensation panels for wind turbine marked its quality during 1997. Later, DC combiner solution for solar PV during 2002. Cape technical seminars and webinars on electrical safety not only help industries to solve their problems, but gave an in-depth knowledge about international standards. Safety for all is the motto. Technical team in Cape is continuously trained to provide end-to-end solution from design to implementation of various safety products and services to the industry. Our speaker today, Mr. Gopak Kumar, probably would have done over 1,000 seminar and webinar in recent time. He is there in every week, traveling across length and breadth of the country, and also on virtual platform is talking about importance of life in the electrical safety. We are all blessed today to have our keynote address, Mr. R.C. Sharma. With his experience, he fought many electrical fires in Delhi. While he was officer in Delhi, he was the first person to respond to the infamous tragedy, Upar Cinema. He was the first one to enter into the building and rescue many people. I'm sure he'll be sharing what caused these major fire and how he came across fighting such fires across, and not only the buildings and also the industries. He is the disaster management expert, MBA graduate in disaster management from IP University in New Delhi, and passed the exams of Institution of Fire Engineers in UK and MI Fire. He was the first director of Delhi Fire Service and DIG Fire in CISF, Ministry of Home Affairs, Government of India. As a DIG Fire, headed the CISF rescue team in Bhuj during the Gujarat earthquake. He is the trained professional from National Fire Service College. He served with Steel Plant Fire Service of Baroko, Bihar, and worked as a fire officer in Delhi Electrical Supply Undertaking and Indian Oil Corporation and Hindustan Aeronautical Limited, HAL, in Bangalore. He's also been consultant advisor to various departments, including Kerala state government projects in the year 2020. He is presently the visiting faculty member in GS of Indraprastha University, Delhi, Haryana Institute of Public Administration, Gurugram, Administrative Training Institute, Nainital, Uttarakhand, and National Institute of Forensic Science, Rohini, Delhi. We have our subject speaker, Mr. S. Gopakumar, who is the director of Cape Electric. He's an engineer, electrical engineer, also one of the members in the working groups of Indian and International Electrical Commission, that is IEC, and the technical coordinator of Lighting Awareness and Research Center, LARC Trivandrum. Having more than 27 years of experience in electrical safety, lighting protection, and EMI and EMC of electrical installation. He has conducted more than 1,000 site studies, hundreds of site studies on failure in electronic equipment, and presented more than 1,000 seminars and training programs. He's also published articles about safety in various magazines and published his own book, The Missing Link, in the subject of electrical safety. Ladies and gentlemen, we are very fortunate to attend this wonderful session on electrical safety. And I now welcome our keynote speaker, Mr. Ashish Sharma, to give opening remarks. Over to you, sir.
Thank you, Mr. Dominic. Well, good morning, everybody. I'm just, I feel very happy that I've been given this opportunity to share my experiences, and probably this should help many of us to really understand the way things went wrong and the way things happened, and we had to face the way the things went. Some of them were very nasty, and we had many people dying. We tried to do our best. Still, we could not save everybody, just like Mr. Dominic mentioned about Upha Cinema. Well, that too was a electrical fire in a transformer at ground level, and probably the same transformer had a fire in the same morning around 7 o'clock. Fire brigade was called, and probably at that time nothing was at stake, so no problems. So some repairs were carried out, and then subsequently, probably in the evening, say around 4:58 or so, around 5 o'clock, the fire took place in the same transformer again. And probably because I was involved in that particular incident during the investigation of the fire, also with the CBRI and maybe other agencies investigating into the cause of fire, it could by and large establish that probably it was one of the loose connection to the transformer, which probably got heated, and the cable just came out, and it just because of the loose joint. This thing was because evening, normally 4:35, it was the month of June, we got tremendous load on the electricity, because in the month of June it's very sultry and maybe very hot, and so the AC air conditioning load is too much on all the buildings. They are using AC, so power load was too much, and because of that probably the heating was a little more than what will happen normally. Probably it didn't happen in the morning, but that time it happened, and probably that cable, just because of the loose contact getting heated and coming out of the nut bolt tightened onto the transformer, fell on the side and caused the burning of the transformer oil cooling fins. Oil started leaking, burning oil came out of the transformer room and set fire to the cars, and that is a big story after that. So only thing I want to just emphasize upon this is that we have seen many electrical fires. I have been in the industries, and during my tenure with CSF, I happened to go to many of the NTPC power plants and maybe refineries and other places where CSF is functional. Apart from my association with the industries for about 15 years, which I gathered was that electrical fires, they keep happening. And many of the times, I tell you, in Delhi Fire Service also, by the time we go to the place, fire is started with a big bang, and we find by the time fire brigade reaches, the fire is extinguished, automatically controlled. Most of the time, when there is nothing to burn next to this electrical fault or something, then things just they cool immediately. They for a few seconds probably, or maybe in a minute or so, big bang will be there. A lot of smoke is there, and if nothing is there to burn, things they come to control automatically. Maybe most of the times you find that some of the safety devices, they may be getting to work and they trip the electric supply. If that happens, maybe whatever is the reason, many of the incidents we find that the fire, this is normally controlled before the arrival of fire department. But then when we look into those things, we find that yes, something has gone wrong. And in fact, in such cases also, it's sometimes when there's an electrical panel fire or something in a thing, and things have on its own, it has a fire is controlled, then we find the room is completely full of smoke. And locating that problem, where was the problem, which panel or was involved in fire, that's a big job. So normally, what I find is that whenever there's an electrical fire, invariably we find huge amount of smoke, and that smoke normally doesn't allow anybody, even he's present there in the vicinity of the where fire has taken place, to locate the seat of fire. So our problem as a fire department is, unless you locate the seat of fire and you're not able to release the your maybe extinguishing media onto the fire, and especially when it is an electrical panel, I mean, injecting that media inside the panel becomes a problem. It's just not feasible at all. So first thing is locating the problem. Then thing is releasing the firefighting extinguishing media into that particular inside. Because if you keep on dousing an electrical panel with anything externally, well, it will not reach inside, and probably it will be wasting the resources, whatever we do have. So that's my personal experience that we do have in many places. In fact, during my visit to the various places, during my course of inspection of the CSF, huge government structure. I mean, we do have a huge investment made on the total flooding of facilities with the clean agents, because electrical, we know that electrical equipment, instruments, if there is a fire, normally we don't use water. So we don't use water. We have to use some clean agents, or maybe which is not creating a problem, or it's not conducting, like a dry powder, or maybe some gases or some clean agents, CO2, or maybe whatever we are using. That's immaterial. But what I have seen in my this experience is that we do have a total flooding system provided, which means that we try to get the information of a fire from the smoke detector, which is installed in the ceiling of the room. And well, fire in a panel, smoke comes out, reaches the ceiling, then it gives an alarm. And then we release automatically a firefighting media is released, maybe from the ceiling. Well, that is, it appears to me it appears very absurd, because fire is inside a panel and we are filling the room. Well, and then maybe that even people are sitting there in the room, even then it is going to happen this way. So best is probably, I think we may have to change our strategy in that sense, because if we detect the fire within the panel and release the firefighting extinguishing media within that panel, we need very small quantity. It is going to be more efficient, and probably otherwise it is not feasible to really use any of the extinguisher to extinguish the fire practically. So now, with that remarks, that's my experience. And Mr. Dominic mentioned about the fire today. Well, we don't have much of the information, but I'm sure that fire happened in one of the flats, whatever it is, whatever could be the reason. That's a different issue to be. Maybe that again it is blamed on electricity, and possibly it could be electricity as well. So whatever could be the reason for that. But one thing, the cause of death must have been because of the smoke inhalation by the people who were trapped there, and probably the smoke has traveled to the other floors, on the upper floors, or maybe on the same floor on the other side. So probably they were affected by smoke. So now this is what the important factor, which for the life safety, when we talk about life safety, is that the built-in facilities in a building, they have to be so designed that in case something goes wrong in one of the part of the building, things should not escalate to the rest of the building horizontally and vertically. So that is here the fire brigade doesn't come into picture directly, because they must have seen the building plans, they must have approved it, they must have seen the firefighting facilities and allowed that occupancy of the building. That's a different issue, but these have to be maintained as well. So probably we'll get to know how things went wrong, or what was the situation there, and what happens basically. So now this, I would like to just, because Mr. Gopakumar is there, he's a well-experienced person. I have heard him a number of times, and he was the faculty in the IP University when we were attending some other training program. So I know that he's an excellent knowledge about the subject. And the most important factor which I gathered from his thing is that at times we provide the MCBs, miniature circuit breakers, but they are oversized, or they are beyond the capacity of this thing. So because as a fire officer, we are our access to these things is limited to that whatever safety devices are there, and whatever they should trip whenever there is a problem. And if they trip, then probably the fire will not escalate, and probably then we can control the fire. It may continue still, maybe some rubber parts or insulation is burning, that we'll have to take care. But yes, this can be taken care of. But if it continues to be power supply is not disconnected, and there is MCB do not trip, or ELCB, whatever is RCCB, they fail to trip, and then that is the biggest problem, because we have seen things happening now. Just the last example I'll quote is, we had number of ventilator fires in hospitals. Mr. Dominic mentioned about hospital fires also. We have seen CCTV footage of some of the COVID hospital in Gujarat. There that in presence of 2 or 3 doctors, a ventilator machine equipment got electrical fire, and they probably could not switch off the power supply. And that within about 80 seconds after the start of fire, the big room where the 5 patients were there, the 4 doctors were barely able to get all of the 5 patients out, and they were able to walk with some support. So luckily, none of them was harmed in this particular fire. But now, when we see that, my thinking is that all these equipment like ventilators, why not provide a MCB onto the equipment itself? Like we have got window ACs, we have got air conditioners in the houses, and all the equipment, we have got a, normally we see that a power cable or maybe an extension cord. Extension cord does have a fuse inside, so that if the power is taken a little more than that, then probably that fuse will trip. It will give way. So now, I don't know, maybe Mr. Gopakumar will come out with something like this. So what I say is that we have got some MCBs and other devices, safety devices onto the circuit in every house. Will it not be better if we have an additional safety onto each and every electrical equipment which is consuming power, so that if something goes wrong with the equipment, we know what ampere it is, what is the power it is consuming. And if we have got a facility which can trip that electric power supply to that equipment, probably most of the problems of electricity, the fires as a result of this type of incidents, which is setting fire to the house and causing that big problem of smoke and other whatever is happening, probably I think that will be something better if we are able to do that. So with this, with just a final word, that most of the electrical fires, they start with a bang, and normally a huge amount of smoke is given out, and wherever these things have happened, on my personal experience, talking to the people what they saw, what happened, they immediately said we had to get out of the room, we had to run away practically. And when we came out, we tried to do something and came back, we could not locate the seat of fire. It was all full of smoke. Now, what I feel is that in such electrical areas, or maybe wherever it is, possibilities there, the smoke venting facility, maybe natural ventilation, especially the common areas where, corridors or maybe stairs, that is very much necessary. Either mechanical ventilation or maybe natural ventilation. So smoke venting should be given a priority where possibility of electrical fire is there. And if we are able to switch off the power supply, I see the 99% fire will be out normally. and then we can use anything, even water can be used. But the fire brigade people are, even we can use water on the live electrical fires also, transformer fires. They are used, they are fought by the high velocity water spray systems. So to that extent, yeah, fire brigade can do it. But we as a normal person, we in the buildings or wherever we are there, we have to be really careful and see that if we are able to cut off the power supply, switch off the power supply, then I think most of the things are taken care of. Firefighting is a subsequent thing. Availability of the other things is will be mattering in that. But for the life safety, the smoke is the biggest killer. We must all know, and probably then we have to take care accordingly. I think, Mr. Dominic, that was something to set the ball rolling, and we do have, then we can have Mr. Gopakumar to come ahead with his presentation.
Yeah.
Thank you.
Thank you, sir. Before we move on to Gopakumar, three things that I understand is, when there's a fire, you can't really avoid fire incidents, fire accidents. So whether we are able to contain the fire within the speed of the fire, we have a good standard, we have NBCs and all that, but how many facilities take care of using the material, what we call passive fire materials, to contain the fire when all the critical rooms, or could be your ICU or X-ray machines and all that, are these materials are protected? Are these a passive fire material are we using? I don't know whether we do audit on that part, whether our fire experts or officers are trained to examine these material. Second is, our electrical installation are at par with international standard, or our own standards are at par with international standard. I think Mr. Gopakumar going to throw this light on us, how far India, so today we're talking about global perspective and Indian standards. Where are we? So many fire incidents, so many fire accidents due to electrical shock. All that we hear is electrical shock. Just read the headline, forget after 7 days, there'll be I'm sure today evening, you'll find a lot of debates on the various news channel, why this happened, why fire department took so much time to come into they don't understand how they can fight within the building even without a department coming to the rescue of or fighting the fire. How do we contain the fire? We don't know. What are the best practices of electrical installation? How far we are improved? So let's hear from Gopakumar. It's a wonderful session. Thank you very much, sir, for giving the wonderful opening remarks. You have 45 years of experience and you fought many fires and you have audited many buildings. I'm sure we are still scratching the surface. We are not even reached 30 or 40% of the expectation as an electrical, as a fire officer. Let's see what, and I'm sure we'll have more time for the question answer. And last time we had 102 questions from group. So I would request, before I give it to Gopakumar, do not put your question in the chat box, because chat box, if you put, it goes off after some time and will not be recorded. I would request everyone to post. If you look down on the screen, there is a Q&A. Okay, box, put all your queries into that. So we will try and cover up as much as possible. Now over to Mr. Gopakumar. Thank you so much.
Thank you very much, Mr. Dominic. Thank you very much, Sharma ji. So it is my turn to start the presentation now. So thank you very much, Sharma ji, for the nice introduction, and thank you very much, Mr. Dominic. So this is the second part of our program on fire due to short circuit. As Sharma ji told, always, every time the results say that electricity created fire and a lot of people are dying. And we always have an interesting discussion about the standards and code of practices. So my experiences, I am a member in the National Building Code in the Electrical Committee. I am in the National Electrical Code of India. A new NEC is upcoming. Probably in next 2-3 months, the new NEC will be out, which will have a lot of new improved safety measures. I am also a member in the TC64 of IEC, International Electrotechnical Commission, in some of the working groups related to safety in the low voltage electrical installation. Also, I am in the TC81, lightning protection group in the IEC and the SC37A, which is the surge protective device. So basically, my nowadays, last 3-4 years, I'm spending more time in the standardization work rather than my business. Now, if we look at how deep these standards are, to explain you very simple, IEC had standards even for insect repeller. Even to that small, you must have seen insect repellers outside the hotels and small restaurants. There is an IEC standard even available for such kind of a very small product. That is the depth the standards are made. But are we following these standards is the biggest question. When it comes to electrical safety or electricity, I have a feeling that people try to read or people try to understand the standard, not to follow it, but to find out how to violate it. So rather than following, the deeply the lines are understood to violate it. As a result, more than understanding, we have more misinterpretation of the standard. As a result, what happens is we don't follow or we don't really take up the subject seriously and do it. Now, coming to my presentation, first I will make a small introduction about my company, Cape Electric. We are, most of you are aware, we are into electrical safety testing and training. We are into earthing system, different kind of earthing system in the sense nowadays, functional or foundation earthing. That means make use of the structural steel in the building. And you don't need any extra earth electrodes in your building. That is the new concept, including extra high voltage installation. You can do this installation. We are already executing hundreds of projects across India. We are also into the business of double insulated electrical enclosures, IP65 enclosures, industrial plugs and sockets, and so on. Basically, electrical installation material. And we are also into EMI/EMC. Or electromagnetic pulse. We are designing a lot of installations where EMP protections are made. This is about the short introduction of the company. And what business we are doing is, about the company. We are a 25 years old company. We have completed. We are going to complete 25 years in next month, February 15th approximately. We are established in 1995. At the moment, we are over 200 employees in 2 manufacturing locations, operating all over India, doing hundreds of projects in India with respect to safety, especially the new and the upcoming buildings. We are actively into training and design. I'm sure you are aware what kind of trainings we are making. So the company started as a Cape Electric Corporation as a proprietorship firm, but then we converted to Cape Electric Private Limited, and now the company is Cape Electric Private Limited. As all of you are aware, fire is a big threat to our country, especially fire due to short circuit. And the claims, very well, some states say 60% fire are due to electricity. Some states say 80% are due to electricity. And if you ask me whether I believe it, honestly speaking, I believe this. Because I am doing several inspections or, the site studies and so on. Most of the time, electricity is the reason for igniting the fire. Probably something else burns too much and becomes a major fire, but the ignition starts from the electricity. As Sharmaji told about the incident in the Gujarat hospital, I'm just showing you the video. Probably people, those who have attended the previous programs, they know the video very well. This video is from the Times of India. What you should understand is the nurses or the staff, they started running and they have identified something. They are trying to remove the patient from the ventilator, but within few seconds, exactly speaking, on the 17th second, small spark happens. 27th second, one more spark, and at 40th second, a major blast happens. And within 1.5 minutes, this particular room was full of smoke. So this whole thing happened within 1 or 2 minutes. Technically speaking, the electrical standards are written and followed in such a way that such electrical accidents are not supposed to happen. Number one, in this particular case, the fire started from an electrical apparatus, let us say a ventilator, probably an air conditioner, this can start, maybe a refrigerator it can start, maybe a heater it can start, any kind of electrical apparatus fire can start. But those product standards are made in such a way that these equipment are not supposed to produce heat. It is not supposed to ignite a fire accident. The safety measures are made internally. In other way, if I say, electrical equipments designed and tested as per the IS standards are supposed not to create fire from electricity, or the chances are absolutely very, very small. But once when you connect this electrical apparatus into your power supply, not only the apparatus has got certain limitations. For example, line to neutral overcurrent, the device overcurrent and short circuit, the device is able to withstand by its own because it has got an internal protective device and it will disconnect. Whereas in case of an earth fault, how you are connecting the earth outside is the important subject. Whether this protective device which is put inside the equipment is able to protect from an earth fault. So there the system earthing comes into picture, and system earthing is decided majorly by the power supply company, and the power supply company are supposed to follow the Central Electricity Authority regulations. This part I covered in my first part last week, 2 weeks back, but still I show you just for people, those who are new in this program. We are supposed to get, for low voltage supply, we are supposed to get a TNS or a TNCS supply from the electricity supply company. Regulation 14.15.16 of the Central Electricity Authority safety regulation says the power supply company is supposed to give an earthed conductor, means a TNS system, or an earthed neutral conductor to the consumer. Then they say this particular conductor, earthed neutral or earthed conductor, shall have an indication of permanent nature, and no cutout or link shall be inserted in this particular line. And then here, where I'm moving the cursor, the electricity supply company is supposed to give an earthed terminal to the consumer, means this earthed terminal is connected to the neutral of the power supply company through a metallic conductor. So that metallic conductor fault return path is very, very absolutely important, because in India, the power supply is the electricity distribution company is giving you a cutout fuse, a porcelain fuse, and this porcelain fuse is supposed to protect our installation in case of a fault. And for this porcelain fuse, it requires a lot of energy to blow or to break, and that energy requires a lot of current, or enough fault current should flow to disconnect the supply. So these are very well documented in the regulations. Also, how to make the meter board is documented in several places, especially the REC documents, Rural Electrification Corporation documents. Since 1970s, these documents are in practice. But unfortunately, what happens is, one moment, let me hide this. Yeah. Unfortunately, what happens is we are supposed to get the TNS supply, but our electricity supply company generally don't provide this fifth conductor. So they don't provide the link between the earth and the earthed neutral conductor. As a result, the network is actually violating the regulations 14, 15, and 16, and the network becomes TT instead of a TNS system. Say, for example, in the hospitals, there are hospitals, those who have got multiple low voltage supply. I have seen a hospital an year back. They have got 4 connections, 4 LT connections, and there are a few operation theaters as well in the hospital. So what happens, if because of the violation from the electricity supply company, due to earth fault, let us say, for example, on the video which we have seen, the ventilator started the fire. Your protective device will not trip. You need to have specific protective devices, additional safety measures for such, disconnection. So basically, if we look at the fire accidents in shops and smaller units and LT supply, most of the time the accidents are due to the violation of the regulation, especially by the electricity supply company. So ideally, these violations shall be treated as a criminal offense. I repeat it always, and in several cases there are the authorities are also taking some measures. Now, case 2, regulation 33. Regulation 33 of the Central Electricity Authority Safety Regulation says. You can read the underlined part. Installation and equipment of voltage not exceeding 650 volt shall be at least 1 mega ohm. What it is? This is the minimum insulation resistance required for in an electrical installation. 1 meg ohm between phase conductors to earth, between neutral conductor to earth. You have to disconnect the neutral and earth link, and you are supposed to measure the insulation resistance, and within your installation 1 meg ohm is the minimum insulation resistance required. I am explaining this because at the last part of the presentation I will show you a product which is sold in the market which actually violates this requirement. Also, regulation 30 says every 5 years we are supposed to, the power supply company is supposed to do this particular testing and ensure that the insulation resistance is higher than 1 mega ohm. If the insulation resistance is higher than 1 mega ohm, the chance of accidents are quite less. Now, these regulations, I had discussion with a lot of electricity supply companies, and in fact, the old engineers know about the regulation, but the new generation engineers doesn't even know about this requirement. As a result, such tests are never carried out by the electricity supply company, not across India, but in most of the places. Another threat which I explained during my last presentation was class 5 and class 2 conductor. In the final circuit, especially inside our houses, especially inside the small scale industries or the low voltage final circuit wiring, or we use the word conduit wiring. We use copper wires in conduits, especially up to 10 square mm copper wires are recommended, and we use copper wires. Now, copper wires are available in 2 types of conductors, class 5 conductor and class 2 conductor. Class 5 conductor is having a higher resistance. In comparison, class 2 is having a lower resistance. The standards, be it IS standard or IEC standard or whatever the standards always consider a class 2 conductor for calculation of different derating figures in a electrical installation. Sometime in the manufacturer's catalog, they must have written the current rating of the wire is 15 amperes. But you cannot use that wire for 15 amperes always. You have to apply the derating factors depending upon the length, depending upon the filling in a conduit, and so on. So in all these cases, class 2 copper is considered, whereas in India, we always use class 5 copper conductor, which is having a higher resistance. Somebody asked me how much is what is the energy loss and what is the payback period of a if we change from class 5 to class 2 conductor, what is the payback period? So I just calculated, not me, it is done by Mr. Sumesh V, electrical inspector of Wayanad, Kerala state. He helped me, or he made this particular table, and finally our calculation, for example, 1.5 square millimeters of wire, imagine 5 ampere current flows through this particular wire. We took a case of 10 coils, approximately, maybe typically for a small scale industry or a small house, 10 hours per day it is working with an actual temperature of 30 degrees centigrade. So this actual 30 degrees centigrade, we actually took these values in a very, very moderate way. The actual temperature probably sometime, is much higher than 30 degrees. Once when the temperature is higher, resistances are also higher, then we are actually ending up into trouble. we have calculated approximately 5 rupees per kilowatt hour, 5 rupees per unit. Here you can see 5 rupees per unit. And the cost of class 5 wire we took from the market 1,254 per coil, and class 2 wire 1,392. Class 2 copper. The difference is the wires are thicker, the strands are thicker. As a result, probably the copper, maybe a little bit more copper has to be used. I'm not aware of such things. That is the job of the the wire companies. Anyway, for a safety engineer, what is important is the offered resistance of that particular wire. Class 2 wire has got a lesser resistance, higher cost. Then with our calculation, we have established that the payback period is less than 3 years. So that means in an installation, if you buy class 2 conductor, of course you will be paying a little bit more, but your payback is within or less than 30 years, 3 years. Now this is actually a moderate calculation, but in a practical case, if we calculate, the payback will be even faster. And what additionally you get is increased safety with a class 2 conductor, because at the end of the day, in case of a problem, in case of an overcurrent, or in case of a short circuit, or in case of earth fault, the protective device should trip. For the protective device, especially for MCB to trip, the fault current comes into picture. Once when the fault current comes into picture, the impedance of the circuit comes into the picture, and the impedance is greatly affected by the resistance of the conductor. So this is a very, very important subject. Last time, in the last program, I made some statements about thermography, and there were a lot of questions in that particular program. I would like to clarify that. I could see that there were about 6-7 questions on thermography, because I made a statement that thermography cannot improve electrical safety in a building. So somebody asked, how come, what is the reason for making that kind of a statement? So I will explain the reason for that particular statement. Let us analyze whether the thermography and arc flash analysis help low voltage system improvement. We are talking about low voltage, not about the other voltages. Please understand. In low voltage engineering, there are fundamental safety requirements. That means the basic safety requirements. It is included in the IEC 60364. That is the IEC standard. In the British standard, the same point is BS7671 or NEC of America, NFPA 70 or IS732 to our, the code of practice of wiring. In all these standards, of course, for us, IS732 is important. We are not bothered about the British standard and American standard. I am just showing you, just for your information. Don't follow British and American standard. We are Indians. We should respect and we should follow our standard. Now, to achieve fundamental safety, 16 inspection points and 10 tests are included in the standard. I repeat, 16 inspection points and 10 tests. Now, if you are making these testing, inspection, and certification TIC points, these are actually mandatory. These are recognized as mandatory safety measures, which is followed worldwide, because the IEC 60364 is followed across the globe as the basic electrical safety requirement. Now, in American standard NFPA 70B and 70E, for OSHA or for to comply to the other enhanced safety measures, additional safety measures, or let us say extras, let me say, thermography and arc flash studies are considered as one among several measures. Please understand, one among several measures. Thermography is not the only one. Arc flash study is not the only one. These are considered one among the several safety measures. But fundamentally, you have to have this 16 plus 10, which is mandatory. And these, the additional things, thermography and arc flash, these are, let me say, extras. After achieving fundamental safety, extras are always good. Extra tests ensure additional safety for you. But Imagine without fundamental safety, if you do only thermography, what kind of guarantee it can give? It cannot give any guarantee. Extras will not guarantee safety. First, you make your fundamental safety proper. Then you make whatever the extra things which you can do. As a result, you enhance the safety. But if you take pictures in a thermal camera and realize, or if you believe that every place is cool, as a result we are not into trouble or expecting safety, is not the correct way. And recently in one of the building, I have even saw a new apartment, a high-rise apartment in Bombay. They are doing thermography to find out loose contacts in the wiring. So they are not doing any of the fundamental safety measures. I would say 90% of the fundamental safety measures are missing, but finally a thermography for the wires which is enclosed inside the conduit are made. This is really, this is not at all acceptable. This is you are violating the basic requirements. So as a result, the statement which I made last time is IEC 60364 or our Indian standard, the IS732, do not recognize thermography as a fundamental test in an LV, low voltage electrical installation. So inside a building, inside an electrical installation, thermography is not recognized as a fundamental safety requirement. If you have fulfilled the fundamental requirement, you can do it extra. So what I would recommend is you first do the test as per the IS732, rectify all the mistakes, then you carry out your extra tests, such as such as your thermography or arc flash study or whatever. But fundamental is there. Without fundamental, if we do only the advanced things, of course, it won't work out. So this is the reason I showed last time that this is misguided, because you please understand that behind every propaganda, there is an industry. Let me repeat, be it a standard or be it a new device or product or service or whatever it is, behind every propaganda, there is an industry. Thermography, of course, will identify the hotspots and it can avoid the hotspots and it will increase the safety. But as I said, example, hospitals conduct thermography and believe they are safe. We were in touch with, in last year after the fire accident, I was visiting some of the hospitals and I asked them how you are ensuring safety. Then the reply is, no, we did thermography and we do thermography every 2 years to ensure safety. But when I asked what about your fundamental testing, in fact, they were never aware of it. So the fact is, protective conductors are non-current carrying. Loose contacts in an earth wire cannot be identified with thermography. And if you really wanted to find out loose contacts, what you should do is you should do the test called as a continuity resistance of the wiring, which is the test number 1 in the sequence of 10 tests recommended in IS732. The second test which I would recommend is the fault loop impedance test, which is the 6th test in the sequence of the IS732. These tests are included in IS732 1989 Code of Practice of Electrical Wiring, 1989. 32 years passed. So many fire accidents, so many electrical accidents in our country. I am yet to see a building which has completed 100% testing as per this particular standard. Hospitals who conducted these tests as per the Code of Practice of India, especially the National Electrical Code 2011, I have put as 0%, because I am yet to see one building where these tests are made. What is the reason? It is because of the no awareness. People are not aware. Now, people ask, what are those inspection and testing points? I have put the inspection points 1 to 19, but all the 19 are not required sometime. The last one, compliance to the EMIMC requirement, that is not mandatory until yet, but probably in future it will come. I will explain in detail the inspection point number 2, presence of fire barriers, other precautions against propagation of fire and protection against thermal effect. This I will explain a little bit later, but what you should understand that there are 16 or 17 inspection points and there are 10 tests. One of the test number 2, insulation resistance. The minimum insulation resistance between a current carrying conductor and earth must be higher than 1 mega ohm. If the resistance is lesser than 1 mega ohm, you are supposed to rectify the problem immediately. Now, I have also included a test number 11. The test number 1 to 10 ensure that your electrical installation, the wiring and the protective devices are operating in a very good condition. But tomorrow, if you plug in some device, portable devices are plugged into your good electrical installation, and if you have a portable device which is faulty, of course fire can happen. In Europe and other countries, they started doing the test number 11, which is called as PAT, portable appliance test. Before you put the portable appliance into your good electrical system, you are supposed to do this test, and you connect only the good electrical apparatus or good portable appliances into your system. As a result, you are able to achieve the safety in a whole way. So basically, if the equipment standards are followed and if the equipment are tested as per the Indian standards, the equipment is unable to create a fire. The chance of fire from the equipment is absolutely less because these tests are mandatory. Number 2, if the 16 inspection and 10 tests are carried out in your electrical installation, plus if you are doing some kind of periodical testing, your installation deteriorations can be identified very, very fast. Number 3, if you are doing PAT, portable appliance test, you will be able to find out the faulty equipment. So all these things are included in the standard, but the question is who is following? Now I go to the second part of the presentation. What is the common cause of ignition of fire? The IEC standard 60695 but this has got several parts. It has recognized how to handle the electrical fire situation in a building. Actually, we can use this methods for fire investigation and failure analysis. In case of a fire, a person who knows the standard, he can actually do the investigation in a better way. But as I said, it is not one standard, even though I put as one. There are several substandards. I think there are about 30 plus standards. So the first cause of electrical fire is short circuit. Why does it happen? It is happening because of a direct contact of conducting live part at different potentials. So your conductors, your wires are having different voltages, and due to an insulation degradation or insulation failure, if these two wires are in touch, of course you get a short circuit. The second problem is gradual degradation of the components. So that means the devices which is used in your equipment, such as capacitors or MOVs or diodes, if it degrades or in a winded a transformer or a small instrument transformer, if the winding insulation fails, of course, it can also create a short circuit. The third part is the sudden failure of a component in the internal part of an equipment. These three are the recognized origins of short circuit, and the consequences or the effect. The effect number 1, always protection device may not get activated. The most important point is, in case of any abnormality, the protective device is supposed to operate within certain time. In case of an overload or overcurrent, for example, the wiring and the MCB, the protective device, are selected in such a way that the conventional disconnection time and the conventional disconnection currents are the whole system is able to withstand. So this we explained the last time, but what I am explaining here is the protective device must get activated, and if the protective device fail to get activated, we will be in trouble. One of the factor which is influencing this parameter is earthing. In case of an earth fault, if your earth fault return path is poor, of course your protective device don't operate. As a result, you will get into trouble. Number 2, the rise in temperature is significant after very short time and maybe localized. That means a hotspot inside your equipment in a very small area. And if the temperature is sustaining for a longer duration, of course, the short circuit happens. And the other reasons are written here. Production of flames. Ignition can occur locally in surrounding components. Possible release of glowing material. Actually, I am only taking some of the bullet points from the standard to tell you that these are the reasons. But each reason, the reasons can be analyzed into detail if we do an investigation. Number two, accidental sparks or arcs. Here, we must understand that there are some electrical apparatus which is inherently it creates arcing while operation. But that arcing is not supposed to ignite a fire. That is much more important. Then accidental sparks or arcs. How does it happen? It can be external to the product. For example, over voltage of the system network. What does it mean? Over voltage of the system network, in the sense, system network means the electricity supply. Due to over voltage in the electricity supply, imagine the line to neutral voltage in the electrical system is 230 volt. But due to a fault on the high voltage side of the transformer, the low voltage side can experience a voltage of up to 1200 volt for 5 seconds between each line and the earth, or neutral and the earth, up to 1200 volt for 5 seconds. Imagine if your equipment is unable to withstand 1200 volt, of course your equipment will fail and it can create a fire. Number two, this 1200 volt which I told, that is the maximum limit which is allowed inside a wiring. This also means the designer, the electricity supply company, has to take care of the transformer in such a way that more than 1200 volt is not allowed inside your electrical installation. But it is very unfortunate that this protective measure is not very well taken care. If you really ask how much voltage can go into an electrical installation, low voltage electrical installation, due to a fault on the high voltage side of the transformer, I would say sometime it is 10 kV or 20 kV or 50-60 kV. Such high voltages can come inside our electrical installation. But remember, the maximum allowed is 1200. So the design must ensure that more than 1200 volt is not allowed inside your electrical installation due to a fault on the high voltage side. This is the exact part of this one line. Then internal causes, sudden failure of components. The consequences are written here. Protective devices may not get activated. That is always the first point of the effect. If the protective devices are not getting activated, or if the MCB didn't trip, of course we will be in trouble. The third problem is high transient peak current due to some kind of switching action, due to lightning, due to starting of a motor, due to switching of a long array of tube lights, and so on. So these also create some insulation failure where the protective device should trip and work and protect your installation. And the fourth cause is abnormal temperature rise due to overcurrent in a conductor, probably due to a defective conductor, probably due to leakage current, loose contacts, failure of a component, mechanical distortions, seizure of a motor shaft. That means the motor is locked and the motor is not running. Premature thermal aging. Why I am showing all these reasons are, there are several reasons which could ignite a fire in a building. Generally, we call this as arc, spark, overload, short circuit, earth fault, and so on. But if we go into deep, there are several reasons, and there are established methods to investigate or to analyze such problems or failure analysis. These are actually very well documented in the standard. Now, protective device. In each of these problems, the protective device is supposed to work and it is supposed to disconnect the supply within certain time. You have no other option. The only option is your protective device should trip. For that, we have different kind of protective device. The first one, is of the category OCPD, over current protective device, means an MCB, MCCB, fuse, and so on. Now, once when you select this protective device, of course, the current rating, there are several measures. For example, if you select an MCB, what is the load requirement? Then the sizing of the conductor shall be calculated based on the load requirement. The sizing of the MCB has to be calculated based on the size of the wire and so on. I'm not going into it, but you always should keep in mind that there is a parameter called conventional disconnection time and conventional disconnection current. What does it mean is the conventional disconnection current is 1.45 times the rated current of that particular protective device. Say, for example, you have a 10 amps MCB. This 10 amps MCB can take a time of up to 1 hour to trip in case of if the current is lesser than 1.45. What does it mean is you have a 10 amps MCB, your overcurrent is 14 amps. How much time will it take the MCB to trip? Up to 1 hour. So your electrical wiring must be able to withstand that much the conventional time it is supposed to withstand. So the electrical design, we are supposed to take care of this particular subject. The overcurrent, it can cause due to overload, short circuit, or earth fault in a TN system. So OCPDs can be used against overload, short circuit, and earth fault in a TN system. Of course, overload and short circuit in all the systems and earth fault in TN system. Then the second protective device is called as RCD, residual current device. We call it as RCCB or CBCT into the plus the earth fault relay. Here, what you should understand is the disconnection current. The maximum allowed disconnection current is 30 milliampere. That means a leakage of more than 30 milliampere. The device RCD is supposed to trip. 30 milliampere is the shock protection in dry areas. This is the maximum current allowed current for shock protection. That means if you wanted to get protection from electric shock, you must use an RCCB of lesser than 30 milliampere. 300 milliampere is calculated as the requirement. Lesser than 300 milliampere is for fire protection. So there are two things: 30 milliampere shock protection and 300 milliampere fire protection. Of course, the 300 milliampere fire protection, we must understand that this is based on a 230 volt line. If the operating voltage is a little bit higher, then there is still a subject of debate going on. So these devices can be used as a residual current device. For non-electrical engineers, you can, I have put a tricky way, current escaping from the circuit. So residual current is the current which is not flowing through a circuit. It is actually escaping from the circuit due to some insulation failure or some leakage. So if the current escaping from the circuit is more than 30 milliampere, your RCD trips. So this is what I mean in RCD, and these devices can be used only for earth fault protection, not for overload and short circuit protection. The third kind of protective device is called as AFDD, arc flash detection device. These devices are used for to protect a circuit from loose contacts. Let us say you have a phase conductor, there is a loose contact, and due to arcing, probably over a period of time it can ignite fire. But this AFDD protects that particular circuit from arcs. So arcing in a conductor due to loosened contacts can be done with AFDD, but don't think that arcing a loose contact in an earth wire will create a tripping, because the earthing is not considered here. Only the line and neutral in case of a single phase circuit. If there is a loose contact, this device will trip. Then the next protective device which is required in your network is the SPD, surge protective device, and I have put and other overvoltage protective measures. And these protective measures actually protects your insulation. SPD, are we using SPDs in every electrical installation? This is quite less. I would say not much. Only in few places, yes, SPDs are used. But the next point, and other overvoltage protective measures, which is very, very important. Say, for example, as I said in the previous slide, a fault on the high voltage side of the transformer it can create a failure and a shock hazard inside our house. So those over voltage maximum allowed inside our building is 1200 volt for 5 seconds. More than that is not allowed, and we need to actually implement all these protective measures in our building. So I would recommend that the electrical designers, those who are listening to the program, please start looking seriously into this particular subject. Then electrical energy as a cause of now let me ask, am I audible, Mr. Dominic? I hope.
Yes, you're audible.
Okay, thank you, sir. Because sometimes sitting alone and talking is too much boring. Thank you, sir. So now, electrical energy causing fire. The IC 60695. One misinterpretation which I wanted to tell you is arc. Whether arc can ignite fire. Arc is a high temperature luminous electrical discharge across a gap. Temperature within the arc can go to several thousands of degrees, but arc is not an effective ignition source for many fuel materials. Even if solid combustible materials, arc cannot ignite because it's for a very short time. Continuous arcing also is considered. The arcing is so brief and localized that solid fuels cannot be ignited or can be difficult to ignite. Fuels within a high surface area to mass ratio may be ignited when contact with the arc. So basically, if we think that the arc is creating a fire, then we have to actually consider the other situations as well. Arc as such cannot ignite fire, provided there is no combustible things nearby. Most of the time, the resistive heating is creating the failure or the fire. Resistive heating, again, the standard established how to calculate it, what is the energy involved, what is the duration involved, and how much energy, how much duration the equipment can withstand. All these things are actually very well documented, and these can be used for investigation and failure analysis. I'm not going much into deep because these are subjects which require a lot of attention. Deep attention is required. One simple concept which is followed is any electrical apparatus which is consuming a power lesser than 15 watts is not supposed to ignite fire. No chance of ignition of fire from an electrical apparatus consuming a power lesser than 15 watts. The same way, a device which is consuming lesser than 100 watts, ignition is possible only under certain conditions. What are those conditions? The condition is if the if some ignitionable things are nearby, probably the other items start burning. An electrical apparatus higher than 100 watts, of course, if the duration is high, of course, the chance of fire is very high in those devices. These are actually the power classification. With respect to time, in the chart, please note that in the x-axis, I am showing the time in seconds, 1, 2, 3, 4, up to 20 seconds. And on the y-axis, you can see the power in watts. Power means the power rating of that particular device. So if the power rating is lesser than 15 watts, the chance of ignition of fire from that particular equipment is lesser. If it is lesser than 100 watts, between 15 to 100 watts, probably it may not or may not create a fire. More than 100 watts, of course, it's danger. Also, the peak power not limited to, I have put 1000, but not limited to 1000 watts. It can be even higher. A device which is even 2 kilowatt, 3 kilowatt, 4 kilowatt. If we are able to limit the fault to less than 15 watts within 3 seconds, then the chance of ignition of fire is less. In simple words, if your MCB trips within 3 seconds, the fire chance is less. Similarly, if the protective device is operating within 5 seconds, the chance of fire is, ignition is possible only under some condition. These are actually some of the concepts which is considered for designing an electrical apparatus plus designing an electrical circuit with respect to safety. So based on this, power source classification comes into picture. I explained this in my last class. Protection from fire of an installation, how does it create? It is due to several reasons, heat accumulation, and I would like to skip this particular part. There are several reasons. One of the reason is in case if you have an equipment which is creating a temperature rise, you should take care of it and you should mount it appropriately so that the temperature rise is not creating a fire hazard. Mounting is important. Special protective devices such as arc flash detection devices are being recommended in the upcoming National Building Code, especially for premises with sleeping accommodation. That means the bedrooms or the hotel rooms. And in special cases, not everywhere, but in some places, you need to have the additional safety measures such as arc flash detection devices. And now today we advertised that we will be discussing more about the condition of evacuation in an emergency, which is very, very important. So in case of a fire, in case of an emergency situation, what are the conditions with which the electrical system should satisfy in order to evacuate people from the fire? There are 4 categories recommended in the electrical engineering standards by IEC 60364, followed worldwide, be it Europe or America or whatever. These classifications are called as BD1 to BD4. BD1 stands for low density easy exit, and the BD4 stands for high density difficult exit. So now, one of the conditions which we need to understand is this classification shall be done by the authority, those who are involved into fire, like say for example, fire and safety department. Basically, they have to set, okay, the building more than 15 meters height and more than this much people are coming under BD2 category. Then they say, for example, a hospital 10 floors coming under BD4 category. So the other categorizations are also there with respect to content of the building, like explosives or flammable things, plus other classifications, say for example, a hospital where people are unable to move. So those classifications are also there, but I am just focusing into the classification or condition of evacuation in case of an emergency. 4 classifications are made. Each classification, such as BD2, BD3 and BD4, special requirements are there. Special wiring rules shall be adopted while designing and erecting the electrical installation. That is more important for us. Now, when it comes to the National Building Code, Part 4, Table 7 explains the classification minimum requirement of firefighting installations. Now, in the upcoming National Electrical Code 2022, in maybe 3-4 months, it will come. What we did is we tried to include, or we tried to combine the requirements of NBC and the IS732 in a different way. If we look at the NBC, service ducts and shafts, 120 minutes, it should be fire resistant. The electrical installation emergency services should have 120 minutes fire resistance. Whereas if we look at the IS732, minimum requirement is 1 hour. But anyway, we have to follow the National Building Code. Emergency lights should switch over within 5 seconds. Battery packed emergency lights are not allowed. These are actually influencing the safety. Now, in in the National Electrical Code, what we did is we tried to simplify the Table 7 of National Building Code and tried to put it in a condensed way with the classification. Building height lesser than 15 meters, more than 15 meters. Because in the regulation, somewhere in the regulation, I think in the 36, regulation number 36 says anything more than 15 meter is considered as a high-rise building. So we also took that particular classification. Buildings category A1, A2, A3 and A4, there if it is lesser than 15 meters, BD1 is the category. And like this, every building, category A, category B, category C, category D, all these are classified. The electrical engineering standards are also classified into it. And now the balance, group E building, group F building, group G, and group H. So everywhere the building classifications are the electrical standards, and the NBC is coordinated in such a way that most of the electrical requirements in future, if somebody asks, look, NBC is categorizing building into this way, and in electrical it is in a different way, where is the coordination? So such answers are handled very well. There are two subjects which is influencing the building classification. One is what kind of special electrical installations are required in order to handle evacuation during an emergency. And the second one is what is the periodic frequency of periodic verification. The regulation number 30 says the insulation resistance shall be tested in every 5 years, but that is actually applicable for the electricity supply company. Whereas inside the electrical installation, this table has been included in the upcoming National Electrical Code. I think before National Electrical Code, next month probably BIS is coming out with a new standard which is called as a guide for implementing electrical standards, guide for implementing standards and regulations. So this guide also included the tables which I am showing. Basically, the building classification and the periodic verification has been incorporated as in line with the National Building Code. Now, what do we require in this classification, BD2, BD3, and BD4? There are special requirements. You can go to clause number 4.2 of IS732, where these classification, these special requirements are very well documented. Say, for example, in condition BD2, BD3, BD4, wiring shall not encroach on escape routes unless the wiring in the wiring system is provided with the sheath or enclosure provided by cable management system itself or by means. Basically, what it says is you cannot hang your wires in the escape route. You have to fix it properly, and you have to have special protective measures. Number two, you cannot use normal light fittings. You need to have special light fittings. So all these special additional requirements are included, and you can see this in the IS732 clause number 4.2, sorry, 4.3, it's not 4.2. Now, wiring system in escape route, actually the wires and the wiring fixing materials, it has to satisfy some special requirements, especially on escape route in buildings BD3 and BD4, because the escape route is not supposed to have a fire or a smoke up to 120 minutes during evacuation or up to certain time during evacuation. I'm just showing you some of the requirements. I didn't put all the requirements here. In condition BD2, BD3, BD4, wiring system that are supplying safety circuits shall have a resistance to fire rating of either the time authorized by the regulation for building elements or 1 hour in the absence of such a regulation. This is what the IS732 says, and as per the NBC, it is 120 minutes. So basically what it says is the wiring must be able to withstand 120 minutes. It is not only the wire. Please understand, we have there is a new IS code for fire resistant wires, but using the wire alone will not ensure safety. The entire electrical wiring, the fixing materials, the distribution board, the entire system should have a function guarantee of 120 minutes. I would say 120 minutes is a little bit larger. It is a little bit higher. Even 60 minutes or 1 hour itself is enough. But anyway, it is the subject of National Building Code. So like this, a lot of additional safety measures are necessary. I skip these points. Anyway, the presentation is available. We will send to you in the mailer. You can take it, or you can simply go to the IS732 clause number 4.3. All these parts are explained. I skip some of them. Now, as I said, I will explain about the out of 16 parts, the inspection clause number 2 explains how to inspect the fire barriers, other precautions against propagation of fire, and the protection against thermal effect. In the previous slides, which I skipped, I told there are several conditions required. Condition number 1, presence of fire barriers. In the standard, it is written only as presence of fire barriers. What does it mean is the person who is doing the inspection should find out whether fire barriers are installed at appropriate location. So then he also understand what is this appropriate location. Say, for example, on the vertical shaft, probably every floor, on the horizontal shaft at certain location. So the person should understand it. Then he has to find out whether the ceiling material is able to handle 120 minutes as per the National Building Code, whether it is tested, check the usage as recommended by in the test certificate and by the manufacturer, and whether the markings and labels are there. So it is the job of the inspector to ensure that all these 5 points are inspected and he is recording it in his report. As a result, out of 3, 1 of the requirement is handled. The second requirement, the propagation of precautions against propagation of fire. How you are stopping the fire from propagating it into critical areas. Here, say for example, fire resistant materials in respective locations, routing of conductors, selection of materials and devices in escape routes. These also must be inspected. Number 3, protection against thermal effect. As I said, you will have some equipment which is producing heat. Have you installed those equipment in such a way that the heat produced inherently because of the operation of the equipment is not destroying the neighboring installations? So all these 3 parts are coming under fire inspection. So the sequence: fire barriers with 5 parts, precaution against propagation of fire, and protection against the thermal effect. All the 3 are important. Now, with the coordination of the testing and the inspection, which is as per the upcoming National Electrical Code as well as the guide, we will have more clarity on this particular subject. With respect to insulation resistance, as I said, the regulation number 33 is very clearly mentioned. Minimum 1 mega ohm within your electrical installation between current carrying conductors, that means phase and neutral, to earth. Minimum 1 mega ohm. But we always use devices which is violating this requirement. One of the example is inverter. Most of the inverters which we use in our residences, houses, it has only single phase changeover. Only phase is changed over. The neutral is not running through the inverter. The same neutral is circulating everywhere. This can create a backfeeding and shock hazard. Lot of incidents are recorded. Plus, this can also create insulation failures, and this can also create fire hazards. So, while using inverters, please ensure that the requirement on the right side, which I am showing, both the phase and the neutral must be isolated. Inverter or UPS circuits shall have separate, the neutral phase and the neutral must be segregated from other parts of the wiring. But unfortunately, the inverter with the 2-pole isolation is quite rare in the market. We have to really search for it. So rather, I would make a statement that we actually use product which is inviting fire rather than protection, inviting. The other product which is used, which is actually inviting fire or accident, is called as a digital grounding device. This is a new trend, or there is a new trend in the industry to use this particular device. The manufacturers claim as a solution for all your problems. They say this will reduce, you don't need earthing, this will absorb fault current, this will absorb neutral current, this will reduce neutral to earth voltage, and all the problems which is faced by the electrical engineer on a daily basis has been solved by this particular product. This is what the manufacturer claims. But actually what they do is they short the phase and neutral inside this particular device, violating not only the regulation, it is a violation of all the safety regulations and all the safety standards. I would recommend, if you use this kind of a device, please remove it immediately. These devices can create harm anytime. It can create shock hazard in your building, it can create fire hazard in your building, it can create failure of electronics in the parallel circuits. Please understand, you are using this device for one circuit, probably that circuit, the problems are camouflaged for a certain time, but the problems will come on the other circuit. So, rather than protecting, we actually use devices which is inviting problem. Now, One solution which we are trying to develop for the last 1 year is we are going to present it during the 25th year of Cape Electric, probably next month. We are coming out with a new solution, SOLVE, safe operation of low voltage electricity. This is a digital based or a software based solution which will explain you step by step what kind of inspection or what kind of safety audits are necessary in a building. As I said, the 16 inspection points and 10 testings are mandatory, fundamentally required in every electrical installation. But since the awareness is quite less, people don't know really what to do and how to do. Now, this software is, it will help you to make the testing, inspection, and certification of a low voltage electrical installation. This also helps you to investigate in case of a failure or in case of a fire accident, because the information, the technical information from almost all the standards will be inbuilt into this particular software, so that step by step you will be able to select and find out the problems. Plus, the software will also help you in making safety measures for a special location, such as the operation theater in a hospital. So we are building, or we are making this software since 1 year. We have a team of 7 engineers working in Cape Electric. Now I will show you the software probably in the next 2-3 minutes. So what we are aiming is SOLVE as a partner in electrical safety. We will support the industry in designing the system. We will train you. We will help you in verification of the basic drawings. We will help you in compliance to ensure the compliance to standards, and we will help you in support during erection, testing, inspection, and certification. We can help you in long-term contract for periodic testing, record maintenance for future, and the last one, PAT, portable appliance test. So here our software is made in such a way. Please understand, this is not a software made in an Excel. We have put a lot of effort and a lot of energy into it, a lot of money into it. So we'll help you to solve your lot of problems. So this is the end of my presentation. But anyway, as I told, I will show you the software as well. One moment, please. I'm sure you are able to see the new screen. Mr. Dominic, are you able to see the new screen?
Yeah.
The presentation. Yeah. So this software, of course, there is a method to log in and all. This software will help you. Say, for example, these are the data which need to be fed into the software. Now, starting with the basic information, like what kind of electricity supply you are having, whether what is the size of the transformer, what kind of supply, TNT, TNS, TNCS, what kind of conductors are used, what kind of protective devices are used at the incoming. Then the supply characteristics, different supply characteristics. Say, for example, you have the mains incoming from the electricity board. You have the alternate supply. Alternate supply, if we select, let us say you have alternate supply and you have AC supply, then it will ask a lot of questions. Then what are the particular, what kind of part of the building you are going to handle, details of main protective conductor, and so on. The various inspection points in the sense, anyway, I am unable to go to that particular part. Various inspection points. Actually, here the real software starts. One moment, I can show it. Basic information, supply characteristics, inspection. What kind of inspections are required? As I said, the 16 inspection points. All the 16 inspection points can be recorded in the software. Please understand that we have also included some additional features, because the 16 points from the IEC probably sometimes is not applicable to India. We need to actually have something extra. So those are also included in the system, say for units. It is not one question. Please look at the inspection points in the consumer unit. Section 1, consumer unit at the distribution board. Section 2, distribution board, what kind of switches are used, what kind of protective devices are used. It is actually a comprehensive method. Then we go to the testing part. There are basic testing features and the final, the detailed testing in the sense. Here, circuit details. I'm just scrolling from left to right. There are several parameters which need to be tested. Actually, these testings are one time. Once when you do a testing as per this particular software, and finally on the summary, you will be able to get how important or how safe your electrical installation and what kind of improvements you are supposed to make, what kind of rectification you are supposed to make in your electrical installation. So with this, I would like to stop my presentation. Thank you very much for all of you to seriously wait for our question answer.
I think this software solve is something very unique which I've seen first time in the country. I think we need to have a dedicated webinar on this, how this can solve the problems of electrical short circuit or shortcoming in the electrical installation. So we have almost a good 23 questions. Ladies and gentlemen, we will take almost 40 minutes to answer. We'll take the question answer for 40 minutes. So those who have not put the question, try and put only one question, because I could see same person putting multiple questions. So I try and avoid putting multiple questions. So we will take the question answer, and I appreciate Mr. Ashish Sharma's patience being waiting to take up the question answer from people. And let's move forward straight away to the question answer. First question is from Narsingha Rao Pujari. He's asking, sir, in an hospital or in a high-rise building having HT supply, if the transformer yard is far away located from the load center, to satisfy the conditions of TNS earthing system, is it required to run the proactive conductor up to the transformer, or the armor cable is sufficient? If it is connected to earth both ends, please clarify. I don't know whether earth or each.
Yes, actually this is not included in foreign countries. Of course, the armoring can be used as a protective conductor, whereas in India, so far it is not included because due to some the old things which is followed. Probably in future, yes. Otherwise, armoring, technically there is no problem in using the armoring as a fault return path to the neutral of the transformer, but until now this is not recognized. So we need to have a separate either a conductor or a strip for the fault return.
Moving forward, sir, Puneet Agarwal is asking, I think Mr. Ashish Sharma can answer, how diluting our statutory provisions for electrical safety are resulting in fire accident?
Well, diluting anything is going to be a problem. I think we in fact, so far as fire service is concerned, they are not really expert, because every building, there is a separate electrical inspector who are giving NOC from those facilities. I mean, they are to be seen, they are to be checked, as Mr. Gopakumar has mentioned, so many checkpoints are there. So in fact, that is very much necessary. And the only thing was that Mr. Gopakumar was mentioning that thermal imaging equipment and all that. In fact, we as a fire person were not really that much conversant with the rules, regulation, and what to check and how to check and how many points. So apparently, because this was the equipment available with the fire services, normally to look for the locating the seat of fire in a smoke-filled area, and maybe locating the people trapped in the smoke conditions. So probably that was something available with us. And we in fact started, I was one of them, the person who was trying to propagate, say, if we are not having that inspection on testing and thatting possible, then probably this was the easiest way to have something. It may be apart from the 10 points or 16 points, that's a different issue. But yes, we thought it is something better than nothing. So, but whatever Mr. Gopakumar says, that is very essential, because the basics things are not provided as per the requirement. Then probably having something superfluous may not be giving that sort of output. That's right.
So moving to Anil Sharma, apart from detection and firefighting, won't you recommend the design of fault level be made mandatory along with the periodicity of electrical audit by TPI, of course, except government agency? As informed, the major culprit in electrical fire is the power supply. Why these power supply companies are not held liable? So, Gopakumar.
This is actually, sir, very, this has got a lot of legal implications as well. There were a lot of cases going on in several high courts. Let us say, for example, Kerala High Court. There was a case going on where the supply company, they have written that for high voltage, extra high voltage, we provide all the safety measures, whereas for low voltage, these safety measures are not possible. Which is, of course, they themselves indicate that these are not possible, which is wrong. The safety measures are very much possible. Only thing is you have to spend a little bit money and implement it. So if you look only into the profits and revenue, and if you don't want to spend money, of course you violate all those things. And making this TNCS system, it's not an expensive thing. You need a wire which is probably 5-inch wire. A small piece of wire, at 5 rupees or 10 rupees is the additional cost which is going to incur. It is actually more than money. It is the knowledge, I would say.
Yeah.
So,
Sir, Indumati is asking, as a consumer, how to identify class 5 and class 2 copper conductor?
I think this is written in the cover of the packing cover of the manufacturer.
Okay. I think most of the answers also were typed by Mr. Harish Sharma. However, I'll take this Shakti Prasad. What is the reason not tripping MCB or MCCB or MCB during fire in circuit equipment for avoiding what to do? Why it's not tripping, even though not tripping the MCB or MCCB, sir?
Sir,
well,
Sharma,
I think he must be saying that he has provided the MCCB, but still not tripping.
Yeah. Shall I reply, sir?
Okay, you can go ahead.
Yeah. Actually, the providing a protective device doesn't mean that it will trip during a problem. You have to appropriately rate it. For example, mostly what we see is you have a requirement of, let us say, 10 amperes, and sometime the electrical person will say, tomorrow my requirement will become 25 amperes. So let me put a 63 amps MCB. Actual requirement is 10 ampere. Only for a circuit of 10 ampere, an MCB of a little bit higher, probably 16 amps is able to protect you. But rather than 16 amps, if you put a 63 amps MCB, and if your wire is rated for 10 ampere or 16 amperes, of course, it won't give any protection. So not only the protective device, appropriate rating is also very much important. So the next question, sir.
So Sandil Kumar is asking, like CU and AI, should the standard mention appropriate cross-section for a particular current for a class 2 or class 5 CU2, sir?
No, it is not like that. Especially for the final circuits, we are supposed to use copper wire. I think up to 10 square mm copper wire is flexible conduits. Flexible wires, copper wires are necessary. The size of line, neutral and earth wire up to 16 square mm shall be same. Number 3, these final circuit wires, we will be pulling through a conduit. Sometimes the length of the conduit is, or sometimes the length of the wire is 5 meter. Probably in another case, the length is 50 meter. So once when the length increases, due to the resistance, increase the resistance, voltage drop will be more. Once when the voltage drop is more, heat accumulated inside the conduit will become more. Now, instead of 2 wires, if you put 4 wires, the amount of heat will be much higher. So technically speaking, the manufacturer will give you some rating of the wire, let us say 10 amperes. But depending upon your application, you are supposed to derate it. Derating factor sometimes is 50%. You cannot use a typical wire for 10 amps always. Sometimes the same wire you should consider only rated for 5 amperes. So it depends on the installation. That is why the calculations, you can look at clause 5.2 or clause number 5.5.2 of IS732, which consists of, I think, totally 74 pages, where all the explanations are given in detail.
Sir, Prabhash Parida is asking, good morning, what is the range of medium voltage panel? Though NBC is mentioned that MV panels should be installed with automatic fire suppression, does any other regulated body mandate the same?
Is it to me?
Yes, I don't.
Okay.
Yeah.
Sorry.
Other than NBC, any other regulatory bodies making the same, I think.
I don't think that this is mentioned only in the NBC at the moment, not in the electrical standards of the National Electrical Code and all. Do not address this issue.
Ajay Kumar, I think this question you already answered in the PPT. However, he says, Gopa sir, can you explain about the fundamental test? I think that 19 test or
yes, we have to have a separate session for that. Probably 2 sessions.
I think one you have to do about solve again the mandatory test. I think if we can do that dedicated seminar only on that 19 test and explaining, I think a lot of awareness can be created.
Yeah.
Okay. Deep Chand Thakur, can PAT be explained in detail?
Yeah, this is also, we will try to explain it probably next time.
I think, yeah, again, the same question was asked earlier also. Sandeep Sharma, which type electrical earthing required at building area?
See, if you have your own transformer, then we are supposed to have either TNS or TNCS. Basically, inside your building, TNS, not TT. TNS is the correct way. So that's all. That is the answer.
Okay. Supriya Kumari, sir, is GFCI used in installation? How important is it? She's asking me your views on this.
Actually, GFCI is a word used in America, ground fault circuit interrupter.
Okay.
In India, these are called as RCCB, residual current circuit breaker. Actually, we should understand that there is a electric war always between the eastern part of Atlantic and the western part of Atlantic. So the European standards comes in one way, or the definitions are in one way, and the Americans are a little bit different. The same device in India we call as a residual current device or RCCB, and they call this as a little bit different. A combination of RCCB and MCB is called as RCBO. Somebody also asked that particular.
Can we use RCBO? I think
yes,
that is the answer. But
yes, basically GFCI in America, their National Electrical Code, which is a little bit different, which asks something extras, where they have included their wording. One of the wording which is always confusing us is earthing and grounding. In India and the IEC standards use the word earthing, whereas in America they use the word grounding. It's only the words. There is nothing different.
Okay. Sir, Sasidhar Krishna is asking, can you please explain some more in 300 milliamps fire protection?
Yeah, actually, for fixed part of the installation, that means imagine you have some kind of machinery or a motor or some kind of, not a portable appliance, a fixed part. This part, due to some reason, it can ignite fire, probably due to an earth fault, due to some leakage. Inside there is some leakage happening and it can ignite a fire. Now, here the concept applied is an earth fault or an earth leakage. In fact, earth leakage more than 60 watts could ignite fire. Now, 60 watts calculated at 230 volt is approximately equal to 300 milliampere. So the set value is made as 300 milliampere. These are, agreements made in the IEC. More than 300 milliampere is not allowed for fire protection. So basically 60 watts is the threshold.
Okay. Sandeep Parmarida, how many resistance pass through human body?
Oh, I think there is a problem in the question. Resistance don't pass through the human body. Only current flows through the human body. Resistance of the human body is calculated as 1000 ohms in dry condition for a person with normal height and weight.
Sir, this is a little bit longer question by Pramod Dwivedi, but I'll try to read for the purpose of the audience here. In my premises, electrical distributing by delta star transformer 11 kV to 230 volt, three-phase supply without using neutral. As a result, we are using only two-phase everywhere to use 220 volt by 2 live wire to operate light and machine. Please confirm by one single phase switch how can we protect the electric shock if any leakage happens, because both the phase is a live wire. Earthing is available everywhere.
Actually, this is well, first of all, I'm surprised to see that this kind of an installation still exists in India. Instead of a single phase and neutral, two phases. I remember during 1998 and 97, during the initial days when we were supplying a protective device called SPDs, surge protection devices, to areas, some of the states in the northern part of India. Small scale industries, they used to buy the device and they used to connect it, and there were a lot of failures. Later we found that instead of neutral, they use a phase, because during daytime, voltage is only 90 volt instead of 230. So instead of neutral, they connect in the place of neutral, they connect a phase. As a result, they could get approximately 200 volt and operate their equipment. But the problem is during night, once when everybody switches off the power, the 90 volt comes back to 230. So at that time, 220, which is connected during daytime, becomes 400. The equipment starts burning. SPDs were starting burning. But of course, this is, I don't think that an electricity supply company will give you or will recommend in this way. If you are using that, actually, this is wrong. Please don't do it. Now, with respect to safety part, if you have connected two phases to your equipment, isolation of one phase is enough to protect that particular equipment. I am not talking about the shock protection. I am talking about the fire protection of that particular equipment. Isolation of one of the phases is enough. Thank you.
Okay, sir. Abdul Zalam is asking, please explain more about AFDD. Sorry.
Yes, AFDD is a protective device. The full form is arc flash detection device. What it does is, in case of any loose contacts, of course, there will be arcing, which will change the wave shape, and that particular device actually disconnects. But don't ask me how it disconnects, because I don't know what kind of sensing mechanisms are used inside to disconnect, but simple, it disconnects. MCB and RCCB, we know how it operates, but AFDD is still unknown to me. But of course, there is a standard available. Indian standards are already published. All the leading manufacturers, such as the global players like Eaton, Schneider, ABB, Legrand, and all of them have got this device.
So there's a question, but name is not mentioned. For underground installation, any BD requirement like substation or any such installation?
I don't understand the question.
Okay, let's dismiss this, sir, because there's no specific name for that. Senil Kumar again is asking, in the slide where power for ignition is discussed, my understanding from the explanation is that a fire ignition can be avoided if the fault can be contained within 3 seconds for load within 15 kilowatt and within 5 seconds for 15 to 100 kilowatt. But ideally, it has to be lower time for higher load, isn't it? Kindly clarify.
Actually, it is not kilowatt, it is watts. 15 watts, less than 15 watts cannot ignite a fire. 15 watts to 100 watts, if some flammable things are nearby, of course, it can ignite a fire. So, number one, this kilowatt is wrong. Watts is the correct way. And now, if for any fault, let us say 4 kilowatt or 5 kilowatt, if this is stopped within 3 seconds, the chance of fire is negligible. If it is stopped within 5 seconds, of course, the chance of fire still exists. But if some flammable things are nearby, then only, the word used is flammable, or it can ignite fire only under certain conditions. These conditions are if something is nearby which catches or which spreads the fire easily.
Sir, question from Dr. Rakesh Chaturvedi, who's quite regular to our various webinars and also a friend of all of us, is asking, what are the tests required to identify the root cause of fire is electrical short circuit? So what are the root cause? How do you identify?
Yeah, sir, basically the inspection and testing, which I told you, 16 inspection points and 10 tests. At the beginning of the electrical installation, that means you have a new house or an industry. Once when you put this service, new installation into service, you are supposed to do all the inspection and test. Periodically, probably you don't need to do all the tests. But if these tests are carried out properly, of course, electrical safety can be found out. You can very well ensure that the fire due to short circuit are completely avoided. Not one test, I would say all the tests are mandatory.
So immediately the 16 test is something that everybody should do. So there is a lack, last time you said, the lack of awareness on this 16 test. Even yes. The 10 test that last time you were mentioning, there's a lack of awareness about the 10 test.
Yeah. Actually, what happens, I was just going through some of the test reports or some of the electrical safety audits made by some international companies in a medical industry, not in a hospital, but in a pharma industry, explosive area. The conventional way of electrical safety audit is to, number one, test the earth electrode resistance. Actually, the earth electrode resistance has been removed from the 10 tests long back. We still do the earth electrode resistance test, which is of course of no use with respect to safety. Other than these tests, what other tests are carried out is most of the installation, whether the rubber mat is there, PPEs are there, signboards are there, danger boards are there, all these things are only inspected. Then the conclusion is 20 more earth electrodes are required and 30 more RCCBs are required. This is the conclusion of the electrical safety audit, which is actually, this is not made as per the standard. This is made on somebody's idea. Now, regarding the PPEs and signboards and all these things, as I said, there are 16 inspection points. One of the inspection point is all these things together, like drawings, PPEs, signboards, signages, and all these things are coming under one. So what about the balance 15 inspection points? And as I said, 10 tests, earth electrode resistance is not there. So what about these tests? So probably, the knowledge is quite, we have to improve a lot. Over to you, Mr. Dominic.
So improve a lot on the knowledge. Yes, of course, this is a third session. So we'll be having another third or fourth session. By then, end of this whole webinar session, that for the entire year, I think our knowledge will also equally improve upon. So Supriya Kumar is asking, earthing in UPS, practical issues, your views.
Earthing in UPS, practical issue. There is no practical issue. I don't know what the meaning of the question is. The practice which is followed in the industry, neutral of the UPS is connected to a separate earth electrode in soil. That is wrong. You are supposed to connect it to the same earth bus bar at the incoming. That means the protective conductor. You are supposed to earth to the protective conductor, not to the separate earth pit. Over to you.
Abdul Salam, once again, can RCCB provide in UPS output used in IT installation? Normally, this is another cause of fire.
Yes, of course. The problem is in a lot of places we use three-phase UPS without with the common neutral, and on the output side, electrical isolation is not made. technically speaking, if you have single phase load connected to a 3-phase UPS, we are supposed to have a galvanic isolation. That means we are supposed to have an isolation transformer at the output of the UPS or somewhere in the UPS.
There's a question for Mr. Ashish Sharma. I think you can compliment Mr. Gopal. Mani Maran is asking what type of cable is recommended for fire and life safety system? Fire survive cable or armored FRLS cable?
Well, the thing is, all these cables which you're talking about, they normally pass through the cable shafts, or that's how it is there. They are protected in that sense. Only there we talk about the maybe the cables which are there for the fire alarm systems, or which are supplying power to the essential facilities. They need to be the FRLS means. FRLS is to the extent it's useful that if there is a fire, it will give less smoke. It will be fire retardant to that extent and gives less smoke. But if it's a otherwise protected with armored and all that, then that's a added protection from probably damage and all that. So probably it doesn't differ. I don't find much this thing from our side. Our requirement is just the systems which are there, which come in operation during a fire condition. They should be able to operate if there is a fire condition in that area. So they are not affected by that. So to that extent, we go into that, but really going into the which one is better, which one is not, I am not really competent. Mr. Gopakumar may say that whether it is a armored cable is better or FRLS cables are better. Just so as to, withstand in case there is a fire, and the thing should be, all the equipment which are required to function should be able to operate with these conditions.
As per the NBC, what they recommend is the fire survey cable to be recommended to use from the power supply, the 220 volt supply to the control panel.
Yeah.
And on the rest of the shaft and all that, either armored or FRLS cable. So this is what I understand. Over to Gopakumar.
Yeah, actually, I would like to correct it. It is not only fire survival cable, complete fire survival installation, including cables, including screws, including fixing materials. Otherwise, fire, cable will survive, but if the cable falls down, then so the whole thing is required. Light fittings, emergency lights, and all those things are required. So it is called as fire survival installation, not wire.
Not wire only.
Sir, Dheeraj Hulal is asking two questions. One is it mandatory to install smoke detector in electrical panel rooms? And second question is, IS 1646 is also relevant code. So over to Mr. Ashish Sharma. Is it mandatory to use smoke detector in electrical panel rooms?
Naturally. See, the thing is, in fact, this IS 3034, this installation of fire safe electrical safety, there it is, things are there. And probably if you are, practically speaking, if you are having a manned premises, then it may not be necessary in that sense, but it may be unmanned at times. So providing this the fire alarm system, whatever it is, smoke again, earlier again, which type of protection you are having, which type of cables are there, probably whether it is a ionization or other type that is there. So optical type, requirement of that will be there. But yes, smoke, because whenever there is electrical fire, smoke is bound to be there. So if detection system is provided, that alone may give you an alarm, yes, something has happened. But then again, for firefighting, again, we have to do something that needs to be provided. And normally these things are connected. And for the automatic firefighting, if it is there, then we need not only the smoke, we need heat also together with this, because it's not working on a single sort of system. It's a dual alarm which should operate all those things. So that is the requirement, depending upon the wherever things are required to be protected.
Yes. Sir, it is recommended to use, in my opinion, with my experience, the tubing system, is what is recommended in the electrical panel. So whenever there's a certain degree of temperature, so the tube ruptures and the suppression happens. So
that's
this
right.
system is what recommended in place of smoke detector.
That's when we talk about detection. Since his question was for detection, but we see on the fire fighting or fire suppression, what you said is perfectly right, because it will not only detect, it will also suppress the fire within that panel. So this is being used nowadays quite a lot. And yes, well, that's okay.
Sir, I'll move on to the very interesting question. Vinay Nagdio is asking, what should be the qualification of an electrical safety auditor? Nowadays, everybody is an auditor.
Mr. Vinay,
is any standard, any code for who should be qualified to called as a electrical safety auditor?
Yeah, sir, the regulation 5A of the Central Electricity Safety Regulation recommends that the state government should authorize the people. So it's a subject of the electrical inspectorate of the state government to qualify, but that is with respect to the mandatory testing. But with respect to the actual testing, of course, we know sometimes the electrical, I don't want to make a comment, but still electrical contractors, there are electrical contractors, those who are, they don't look into the drawing, they only do signing. So the safety auditors, if this kind of, safety auditors comes into picture, then that will be a risky thing. We have to be careful. Of course, a person who is knowledgeable in the standards and codes and practices has to become the safety engineer.
Okay, I'll take best 3 questions because we are nearing 104, 105. So I'll take 3 questions. Subhash is asking what is the cost of the solve. So what we do is we're going to answer to all these questions. So we have your details here, Subhash P. So Mr. Gopakumar will revert back to you individually for this. And this software again on Solve, we will be doing a presentation how it's going to help the whole industry and the nation especially. And if we are not answering to any of this question, rest assured, Mr. Gopakumar personally will come back to you, will write to you with an answer. However, I'll pick 3 questions which is below this. Sharma is something. My name is popped up, so I'm just reading. Mr. Dominic and Sharma told chances of electrical shock as electricity is alive in some cases, which is dangerous, risky. So no, I'll skip. Vinod B, whether we can go for a wire with copper or aluminum for 3-phase power supply, especially the domestic area or to the industrial area. Question to Gopakumar.
Whether we can go with copper
or aluminum for 3-phase power supply.
I don't know what he meant, whether the power supply connected from the transformer into the house or within the house. Within the house, of course, copper. Probably from the transformer up to the house, if the sizes are higher, you can go for aluminum.
Okay. James Cootie Thomas, let them install the sensing CTs both for phases. So this I think you can answer. Amit Kumar, how to investigate that any fire incident occurred due to electrical short circuit, sir? As you have done a lot of 45 years, Ashish Sharma ji, how do you investigate?
Well, which is a really difficult job, really difficult job. Because normally when there is a fire, almost everything is burnt into that, all the evidences and how things went on, all that. But well, it depends. Still, it is feasible. Then we need to involve the forensic people in that, because normally fire brigade people, they are not having that expertise. So in cases where something like that happens, we normally take help from the forensic department. And normally this is done only in cases where some deaths have taken place. Some people have died during a fire incident. The cause of fire and other things are investigated. But normally, the fire services in the most of the state fire services, we do not have that sort of expertise to really do that, and nor they are mandated. In some of the state acts, they say that they will be able to, they should be investigating into the cause of fire. But as of so far as I know, we are not really going into that in details to that extent, because we don't have facilities. It needs a very highly expertised technical people and equipment and facilities knowledge as well. So that's there as it stands now.
So Shweta, I could say this time there are a lot of ladies have participated. So I'll take this Shweta Kare. For control cables, do we use PVC or XLPE insulation, and why?
For control cable, do we use PVC or XLPE?
Yeah, XLPE.
PVC cable, with respect to safety, the requirement is the temperature has to be limited in normal condition to less than 70 degrees centigrade. Whereas in XLPE, it can go up to 90 degrees. So this has something to do with the temperature classification of the wire, plus the insulation behaviors are higher in case of an XLPE cable. But control cable PVC or XLPE, most of the time for industrial purposes, XLPE is used. PVC is not much used. This is what I have seen.
So the last question for the day, Saurabh JJ, what to do when earthing of homes not getting in industrial area due to poor soil condition, even though plenty of water giving to earth pits?
So this is always, a subject of big debate. This earth pit has nothing to do with safety. As I told, the 10 tests, earth pit, earth electrode resistance measurement has been already removed. So earth electrode resistance, of course, is required only for lightning protection point of view. But nowadays, modern buildings have foundation earthing or foundation, the systems which is incorporating the structural steel, where the earth electrode resistance is again not an important subject. But if you have a standalone equipment, some kind of electronic equipment, and you try to make 1 ohm resistance, this has nothing to do with safety or the reliability of the system. It's a simple misinterpretation. You don't require an earth electrode of 1 ohm anywhere. It's a misinterpretation. Thank you.
Thank you, Sharma ji. Thank you, Gopakumar ji. And this is very, very informative. And I could see, the companies, a lot of multinational, like we have Adani's and Reliance, and a lot of electrical inspectors participated, and there are a few multinational companies also participated. I think this is a knowledge session that we've been doing in most of these Saturdays. Soon we'll have another session on the necessary test. It could be 10 tests or 16 tests. We will do that eye-opening webinar, and followed by Sol. So we will continue to come forward with the educational program, and all the participants I'm requesting, please invite your friends and contact, because these are the programs that can develop our nation, move to the next level. So as Mr. Gopakumar was saying, we don't even follow one standard of the international code. Okay, so let's start beginning to understand what are the necessary tests that we must conduct to be safe in a building. So I want to thank everyone for participating. As I said, Mr. Gopakumar email IDs continuously we have been putting in the chat box. If you're not posted your question, you can always get back to him on his mail. And Mr. Sharmaji's mail ID also has been posted here. So those who want related to a fire, they can always get back to Mr. Sharmaji's mail. And we'll come back again soon. We'll declare the next webinar by Tuesday or Wednesday. The recording, the PPT and the recording will be shared by Tuesday to all the participants who are registered. You will get it on your mail. So please check your mail either on Tuesday or Wednesday. We'll get back to you. And thank you so much. We had a wonderful session, and the question answer, we couldn't take much, but however, you'll be answered personally by Mr. Gopakumar. Thank you. Have a wonderful day. Have a safe day. Thank you so much. Thank you. Bye-bye.
Thanks, Mr. Dominic. Thank you, Sharma ji. Thanks.
Thank you. Bye, sir.
Thanks for the support. Thank you. Bye.
Thank you, sir. Bye-bye.